Today we're going to talk about changing one dimension in a rectangular prism, or actually in any prism. One of the objectives we have, remember, is that they will change one dimension on you, not all three, not two, just one. They'll either change the length or the width or the height, and then you have to kind of compare and see what happens. So what we're going to be doing here is comparing what happens from the original prism to the new prism. Now, if you recall in class, we already did a couple things here. We already figured out that the parts that changed, in this case was the height. So the 2 meters for the height here became 6 meters here. We also realized that that was a scale factor of 3. We're multiplying by 3 to get the new height. So what we're going to do is, now that we know that information, we're going to figure out the volumes of both of these prisms and then see if there's any kind of correlation there. So to find the volume of a prism, remember I've been telling you to use this formula because this works with all of our prisms. The area of the base times the height of the whole prism. So if you think of that formula there, that should help you out. And then it leads us to the actual formula, because the area of the base here, the base is a square or rectangle, depending on how you want to call this, but it is obviously a rectangle. But it's length times width. And then the height would just be the h. So this is the actual formula that you see on your formula sheet. But again, if you use this one here, it's going to lead you to the formula that you need. So volume is equal to, the length was 5, the width is 2, and the height is what we're looking at on this changing thing. As we do the math here, we wind up with 20, and this is meters cubed. So there's our volume for our original prism. If we look at the next one, I'm going to just start here because we already have our first formula. So this is going to be 5 times 2. That first part's the same, but now we're timesing it by 6 because that was what changed on our new prism here. So when I do the math here, I wind up with 60 meters cubed. All right, so we need to compare these. First of all, we already know that when we changed this height to this height here, it was a scale factor of 3. So does that hold true for this? I had 20 meters cubed. If I times this by 3, do we get this answer here? And we do. That is, so far it seems like what happens. If I change the dimension by a scale factor of 3, then my volume changes by a scale factor of 3. Let's look at the second one, and let's see if this does the same thing. This time I have a cylinder. I'm going to call this the radius. The 1 is the radius. We're just going to make our life a little easier there with that. So again, area of the base times the height, because that's going to be our standard formula to help us with all these. And again, height, remember, is referring to the height of the prism. If you need to, you might even write that word in there if you needed it. Okay, so again, the base, we're looking at the base. The base is clearly a circle. To find the area of the circle is pi r squared. And now we have the height of the prism. Oh, and actually, I'm sorry, I should back up a minute. Again, we looked here, our height was 4.5 on this one, and on our new one, our height is 45. So we can tell that it was a scale factor of timesing it by 10. Because again, remember 4.5, if we times it by 10, all we're doing is moving our decimal one place to the right, and then that gives us the 45 that we had up there for the second one. All right, so let's plug in our numbers. Pi is 3.14. The radius, I said, was 1, so that's going to be 1 times 1, because 1 squared is 1 times 1. And then times the height, which is 4.5. When I do all that math, now again, these sort of cancel out because it 1 times anything. So when I do the math here, though, I get 14.13 millimeters cubed. Okay, so there's my original volume on my first shape on the original cylinder. So let's do the second one here. Volume is equal to pi r squared times the height. Volume then is equal to 3.14. The radius, remember, did not change, so that's still times 1 times 1. You can put 1 squared if you want to, or whatever the radius was squared, but I just think it's easier to show it like this. Now the height is what changed this time, so now I have the height of 45. When I do the math, I get 141.3 millimeters cubed. Okay, so we actually already looked and we said we were trying to figure out, or we saw that our height here was 4.5. We said if we times it by 10, that we wind up with the 45 millimeters here. Does that hold true for our volume? If I have this number here and I times it by 10, do I get this volume here? And I do, because again, just moving the decimal one place to the right gives me the 141.3. Okay, so we're liking this. Let's try one more just to make sure. This one starts off with a cube. Again, volume is equal to area of the base times the height of the whole prism. We start off with 3 yards here for our base, or excuse me, for our length or our width, whichever one you want to call this, and then it went to 15. So this was a scale factor of timesing it by 5. Again, we did this part in class already. So if I do the math, length times width times height gives me 3 times 3 times 3 on this one, which gives me 27 yards cubed. So there's my original volume. Let's look at the next volume. Again, length times width times height. So the only thing that changed here was the length. So this is 15 now, and the width and the height are the same. Times 3 times 3, just like the first time. And we get 135 yards cubed. So we said that we went going from, which our changing of our one dimension was timesing by 5. Did that hold true here? If I times this by 5, do I get 135? And I do. So on the back of this worksheet that you have, you'll notice that there were 5 questions. So I've kind of answered a couple of these for you. Make sure that you are finishing with those questions on that worksheet. The next worksheet we have was what we did today in class, which is the surface area. Now I showed you a couple different ways, or 2 different ways to find surface area. I'm going to do your prism, your cylinder, and your triangular prism. I should say your rectangular prism first. So surface area. The way that I would suggest that you do it is we're going to break this apart into the different parts that it has. We know that if it's a rectangular prism, I have a front and a back. So I'm going to make one of my rectangles be the front and the back. We also have another rectangle that would be the side and the side. Because, of course, if I have a front, there's a back that's the same, a side, the other side is the same. And then the same thing here, this is going to be now top and bottom because they're the same. Okay, so once I do this, I need to then figure out what my different dimensions are for the different rectangles. So I'm going to start with the front and the back. And it's going to be a little difficult to shade this, so I'm going to do it separately each time. I'll erase each time. But the front would be this part right here. Let me outline it first. This would be the front of my prism. And so I'm looking at this measurement here, and I need this measurement here. Well, it's over here on the other side, so this is 6. So my front and my back is 4 by 6. Okay, so that's that one. Actually, I'll try to do another color here to show you the next one. My side and side would be this part here. Here's the side. Again, remember, if we're looking straight on it, that would be a rectangle. And then this is my what I'm looking for. So I'm looking at this one here, 2 feet by 6 feet. So this one is going to be 2 by 6. And then the last one is the top. There's my top and bottom. And so again, I'm looking at this side here, which is going to be 4. And then this side here, which is the same that's down here. So that's 2. I'm going to write it over on this side. So we have 2 by 4. Now, I kind of showed you some different ways even I'm doing this because we've done so much with just area of a rectangle or a square. We know that it's length times width, but let's go ahead and write it one more time. Area equals length times width. That means the area equals 4 times 6. So area is equal to 24. What are we doing here? This was feet squared. Okay. Now that's only for one of our triangles, or rectangles, excuse me. But we know we have 2 of them. So I need to either times it by 2 or add it together. So I'm just going to times by 2. That gives me 48 feet squared. Now I could go ahead and write it right inside here because that's going to be both the front and the back together. I'm going to do the same thing for the side and side. So I know it's 2 times 6 That equals 12. I'm going to times it by 2. That gives me 24. So both sides together are 24. My top and bottom, that's 2 times 4. That's 8. And again, if I wanted to add it, I could do it this way. 8 plus 8 is 16. So my top and bottom together are 16. Once I do it this way, now I have to go through and just add them all up. It's just like if I was finding a composite area of some strange shape. So it's the same idea. I'm going to add up everything I circled here because that included, this is the front and the back. Let me do another color. This is the front and the back. This is the side and side. And this is the top and the bottom already added up together. So now I'm going to add those 3 numbers. So when I do that, I get a surface area of 88 feet squared. Now, we do have a formula that we can use. And if you would prefer to use the formula, you can certainly do that. If you're going to use the formula, though, I'm going to give you another little tip that you need to make sure you do. Surface area, if you look at your formula sheet, it's 2LW plus 2LH plus 2HW. Or it actually might say WH, but it's the same idea. The first thing I would do, let me go back up here a minute, is I'm going to go ahead and write down what is my L, what is my W, and what is my H. I have to know this to plug it in correctly in my answer. So the length is 4, the width is 2, and the height is 6. All right, so we've got that. So I'm just going to go ahead and plug it in. Wherever I see an L, I'm going to plug in 4. Wherever I see a W, I'm going to plug in 2. Wherever I see an H, I'm going to plug in 6. So I have 2 times the length is 4, the width is 2, plus 2 times, again, the length is 4, the height this time is 6, plus 2 times, the height is 6, and the width is 2. Once I do all that math, I'm just multiplying each one of these out together, and I'm going to add them all up. Once I do that, I get, again, 88 feet squared. Remember, we're doing area, but it's surface area, so it's only square units. Okay, so that's how we're doing that. Still get the same answer. All right, next one here, we have a cylinder. Okay, so with the cylinder, we are going to do the same thing. I have 2 circles. So I'm going to use these 2 circles here. They're the same size. The radius is 3, which gives me a diameter of 6. Remember, I always do that whenever I have a circle. Put what the R is, put what the D is, because it just helps you out later on when you're doing stuff. And on this one especially, it's going to help to have both. All right, so the 2 circles are pretty easy. I'm going to find the area of both of those. So area is equal to pi r squared. So area equals 3.14. Radius, remember, we already said right up here, radius is 3. So it's 3 times 3. Again, if you want to put in 3 squared, you can, but I think sometimes just typing it in your calculator as 3.14, multiplication sign, 3, multiplication sign, 3, it makes it a little easier to get your answer. Okay, so when we do this math here, we wind up with 28.26 inches squared. Remember again, though, we have 2 of them. Now I can do 2 things. Actually, I might do it this way this time. I'm going to write 28.26. There's one of them, and here's the other one, 28.26. Okay. Now the thing is, we also have the lateral side, which is the part that I'm going to, for lack of a better word, I'm going to call it the label. If we think of this picture as a soup can laying down, then we would have, we can call this the label. So I'm going to actually write like S-O-U-P on this. Okay, so that would be like a soup label. Remember, if I take that label off, it makes a rectangle. We kind of demonstrated this in class today. You've seen it, I'm sure, in 6th grade and 7th grade also. Now, this part of my label is the height of the label, which is the same as the height of my prism. So that's going to be 6. Now this part, so that's my width, because I'm going to do length times width. The length, though, this part here was the circle. This length from here to here was the circle that went from here all the way around to here. But what happened is when I undid the label and I unrolled it, it became a rectangle. So now this becomes my length. But remember, it started off as a circle. And so what I need to do to find the length is I'm finding the circumference of the circle. And circumference, remember, is pi d. So now I'm going to go ahead and do this formula. So I'm finding, this is my first one. This is my my circles, excuse me. So now I have area equals length times width. This time though, my length is pi d. That's going to be my length. And then times the width. So area equals 3.14. Again, I have my d already. My d is 6. So times 6 times 6 again, because 6 happens to be my width as well. So that's the only reason why it's 6 again. When I do this math, I wind up with 113.04 inches squared. Remember, you can use your calculator. That's perfectly fine. All right, so this is my label, which I'm going to put in here, 113.04 inches squared. All right, but again, composite area, right? I've got my label, which was my lateral side, the part that was curved around the soup can, if we think of it that way. So I have this, and then I also have my 2 circles. So I need to add it all up. When I add all of them up together, my surface area becomes 169.56 inches squared. There's my total surface area. Now, again, if you wanted to, you could use your formula that's right on your formula sheet. And this is what the formula is. We have surface area equals 2 pi r squared plus 2 pi r h. Now, what we're looking at when we do this is this pi r squared. There's my area of a circle right there. This 2 pi r is the same as pi d, which is the circumference of the circle. So remember, I have 2 circles, so that's where I get the 2 pi r. That's 2 times the area of the circle. And then this is my circumference times the height of the circle, which was that length and width that I did a moment ago. But again, we're just going to go ahead and plug in our numbers. So surface area is equal to 2 times 3.14 times the radius. We already said, let's look back up. Radius was 3. Okay, so times 3 times 3 plus 2 times pi, 3.14, times the radius, again we already said was 3, times the height, which was 6, the height of the prism. Remember, that h right here is the height of the prism. All right, again, once I do all the math here and I do all my multiplication here and all my multiplication here and then add them together, I still wind up with the same thing. I'm going to get 169.56 inches squared. So there's my surface area of my cylinder. Last one we're going to talk about is now the surface area of a triangular prism. Remember that a prism is always labeled for the bases. Now this is a triangle here, and then there's a triangle on the other end. Even though it looks like it's sitting on the rectangle that's on the bottom, so to speak, those triangles are the name of the base. It's a triangular prism. So as I just showed you, we have 2 triangles. They look like this. They have a little right angle there, and we have 4 by 3, and this is 5. So to find, I need the areas again. So to find the area of a triangle, it's half base times height. So area equals half. The base is right here. The base is 4. And then the height is 3. We do not need, at this point, we do not need the 5 that is given to us on the hypotenuse. We don't need that. Remember, just plug in what you need. I need the base, and I need the height right there. That's all I need, because I got the base of the triangle and the height of the triangle. Okay, make it easy on yourself. Remember, what's half of 4? Half of 4 is 2, so I can change that to a 2. And then 2 times 3 is 6. So this becomes 6 millimeters squared. But remember, I have 2 triangles, so we're going to times it by 2. So I get 12 millimeters squared. This is for my 2, oh, I should say area of 2 triangles equals this. All right, so I've got part of it done. Now remember, my 2 triangles are being connected by rectangles. I'm going to try to, again, draw this out as best I can. I have a rectangle kind of in the back. So it's this one that's in the back here. Again, if I do this, that's the rectangle. Again, it's something you have to try to see as you're doing this, but that's the back part there. So, but I do have 3 rectangles. So I'm going to go ahead and draw all 3 of them out first of all and try to show you an easy way to look at this. Now again, each rectangle is touching an edge of my triangle. There's one edge, there's another edge, and there's another edge. And we already determined that each edge of my triangle has a different measurement. One of them is 4, one of them is 3, and one of them is 5. So that means on my rectangles, one of these is going to be 3, one is going to be 4, and one is going to be 5. Now what I need to know is how tall is my rectangle, or what's the length of my rectangle. Remember, I'm connecting the two triangles together. So it's this triangle being connected to this triangle up here, and they're connected by that line right there, and then this line right here. So that's what it's connected by. So that means my height is 7. Now again, we've done so much of our finding area of a rectangle, so it's pretty easy. We're just going to do the multiplication. 3 times 7 is 21. And then 4 times 7, this was 7 and this is 7. 4 times 7 is 28. And 5 times 7 is 35. So I have each of my rectangles represented, and I have my two triangles represented. I'm going to add them all up. That means I have 12, because that's my two triangles right here, plus my first rectangle, plus my second rectangle, plus my third rectangle. And when I do that math, I wind up with 96 millimeters squared. Okay? Now this one has a tricky formula to do. Again, I really would suggest that you work it out the first way. I think it's going to be a little bit easier, because this time now we have surface area. If you look on your formula sheet, it says this, HP plus 2 big B. So now we have a lot to make sure we remember what it is. H here, this is the height of the prism. And it doesn't say any of this on the formula. So if you don't know this, you really can't use it, because you need to memorize this part of it. This P here is the perimeter. But again, it's tricky, because it's not the perimeter of the whole shape, which is kind of, you can't really do that. It's the perimeter of the base. And the base in this case, again, is a triangle. So we're looking at the perimeter just of the triangle. Then this base here, or this capital B, is the base, but remember, it's the area. The big B is the area of the base. And again, it means it's a triangle that we're looking at there. So there's kind of a lot going on with this formula. So you want to really be careful. If you like the formula, then you can use it. But if you're having any kind of trouble, I would suggest you do it the way I just showed you, where you're breaking it apart, finding individual areas, and then putting them back together. Okay, so now we have, let's go ahead and write it down though, so what it would look like. The height of the prism, let's go back. Height of the prism, remember, is this part right here, so it's going to be 7. So I'm going to put in 7 there. Height of the prism is 7. My perimeter, again, is the perimeter of the rectangle, excuse me, of the triangle, and so I'm adding these up. 4 plus 5 plus 3. So that's going to give me 12. There's my perimeter. And then I'm going to add to that 2 times the area of the base, remember, which is going to be the 1/2 base times height, so it's 3 times 4. So it's half times 3 times 4. Okay, once I do all that math there, surface area, I wind up with, again, 96 millimeters squared. So I don't care how you work it out. You do need to make sure you're showing all your work. Make sure you're drawing pictures if you need to, like we did on this first one, or excuse me, where we broke it apart. We've got our triangle picture and our rectangles. But do make sure that you're showing all your work, or if you're just going to use the formula straight from the formula sheet, again, make sure you know what you're doing. This was the formula, then you're going to plug in your numbers, and then you're going to have your answer. So this should help you with the little quiz that's on Edmodo today. Good luck, and I'll see you next class.